Hello, I want to present you a very simple program, less than 300 rows of code in C Sharp that will show you how people usually don't understand what they are doing when they try to find a path in a map, in a labyrinth, in a database with complex connections and everything. Usually people try to work with recursive algorithms. They work, of course, but just to illustrate that, I will show you the most commonly used three algorithms, actually two, the third one is mine, that explore the labyrinth and find a path in the labyrinth. Everyone knows about the algorithms breadth first search and depth first search. They are written in these well-known books about everything about the algorithms, but I tried just to illustrate it. So initially I thought that there are many different algorithms to find a path in the labyrinth, but finally I realized that there's only one. You start from a point, and after that you start to look around and you find some free places and you will put them in the list. And after that, the only difference between all the algorithms is how you will treat that list, as a queue, as a stack, or just as a simple list with some numbers in it. If you treat it as a queue, that means first in, first out, this will produce simply BFS, breadth first search. That means that you will explore everything that you have visited around before going ahead. Depth first search is exactly the opposite. It happens if you treat this as a stack, and in this case you will continue from the point where you have been recently and just will continue your way ahead. And there's another approach, just to take some random number in that list, no matter what, and to use it as a starting point to explore the labyrinth. So I will compile the program. Actually, all the difference between these three algorithms are hidden in this small piece of code. In the first case, I will take the first member, which means Q. If I have DFS, I will take the last number, which means the number of waiting to be visited points, -1, and you know why. And in the last case, I will just take randomly some of these points. And now I don't know what will happen, because my program generates the labyrinth randomly. Density is given here, which means the percentage of let's say bricks, obstacles in our labyrinth. I'm not even sure that the path here is possibly to some stupid labyrinth to be generated where there's no path. But first, let's try with BFS. That's the most predictable algorithm. It will explore everything. You will see how this happened. Start. These yellow points, small yellow points, illustrate where are the points that really still wait to be visited. And in BFS model, it's a queue, which means that the first one which appears in the list will be the first one in the queue, and finally all these colors here show actually the distance from the starting point to the end, and you will see something like waves. It looks like people moving together and exploring everything, and the only parts that are not explored are actually these white areas, and they are not explored because there is no way to them. So actually we know everything about this labyrinth. We found the shortest path, that's sure. With BFS we always find the shortest path. But what's the price? We have to explore everything. Let's try with the commonly used algorithm DFS, depth first search, that people usually prefer because it's much more easy to be implemented using recursion. That means that if you are somewhere here, first you will look around and you will forget about all these points that you have visited a long time ago, and will start ahead. Yeah, it moves somehow. Oops. And it found a solution. It found the solution. The solution, the time was probably the half of the BFS case, because half of the algorithm is not explored. But look at the length. The other property of DFS is that it's unpredictable. It's based on random numbers. So if I run it again, it will give me completely different answer to the question. Probably better one. I don't believe. Again. And if we start it again, we'll find something again completely different, because we just move around looking what's free around us, don't look back, and with some hope that we'll find something. 188, that's not good. Random, that means that we're somewhere in between. Here we have a lot of free places. That means that we have decision very fast. Probably not very, but this algorithm could be improved if you know where you're going, just to move in that direction. Then it works much faster. If it's random, then we will just take at random some point in the list, and it will happen something that's between breadth first search and depth first search. So probably we will not explore all the labyrinth, but we will find the solution, and look at that. It finds even the better solution than VFS. Oh, I have pressed generate. Excuse me. Generate means a new labyrinth. BFS will also find 100. I'm sure. BFS always finds the best solution. Yes, that's right. Just press generate and I changed the algorithm during the presentation. So 100 is the best solution, but we have to explore everything to find the best solution. DFS, on the other hand, gives us a chance, if we are lucky, to find the path more efficiently. Yes, but look at the length. Half of the labyrinth is not explored, especially this part here, where you can cross from here to here. These points were not visited by DFS. Now it's up to you to decide what to use, and you have to know there's only one algorithm. The only difference is where you will take the point that you will have to visit from the end, from the beginning, somewhere at random in between. Thank you for the attention.